All right, this lesson is Chem Quest number 8, and it is on the structure of the atom. So the first page of our notes is just information that we need to analyze and learn, and then from there we'll answer the critical thinking questions. So I like to really look at everything that I'm given, look at the diagrams, look at what all these little dots are and what they mean. And when we do that, if we do a good job at it, when we get to the critical thinking questions, they're not going to be hard at all, and we'll be able to figure out what the answers are. So let's look at this and see what's going on. Information, structure of the atom. Note the following symbols. So we've got some symbols to look at, and we've got, the first one is a white circle, and that represents a proton. The proton has a positive charge. I like to represent the proton with a symbol that I typically use all the time, and that is P with a plus sign. So when I'm taking my notes, that is my shorthand for a proton. Not only is it a good shorthand thing, but it reminds me that a proton is a positive charge. So if you start using this, that's one thing that you'll be able to pick up and learn. All right, and then the black dots are representing electrons, and they have a negative charge. So my shorthand for electrons is an E with a negative. And then the next subatomic particle they have is a gray dot representing a neutron, and it does not have a charge. So a neutron I represent with an N with a 0 with no charge. This information right here is something you need to know, and basically you just need to have it memorized so you can answer questions about it without having to think, what is the charge of a proton? It should just be in your head and just come out very quickly. All right, let's look at the diagrams we have. We have 3 boxes here, and they're representing hydrogen atoms. So we're told that they're representing hydrogen atoms. Okay, so in the first box, I notice that I have a proton and I have an electron. I've got one of each. And then I notice these numbers here. It's 1 and 1. Okay, and then H is the symbol for hydrogen. I know that because we've memorized the symbol, so we know that's hydrogen. Plus he told us. All right, in the second box, I've got a new dot here. I do have my electron and I have my proton, but now I've got this one. That is a neutron. And then I notice these numbers changed. The top number is now 2, but I have 3 dots. So what is that top number representing? Okay, so looking at the third picture, we've got our 1 electron. It's the same. We've got 1 proton. That's the same. But notice we have 2 gray dots. And then another thing I notice is my number on the top changed to 3. So here it was 1, here it was 2, and here it was 3. So what is that number representing? That's what you need to ask yourself. So let's go ahead and look at the carbon atoms. All right, the following 3 diagrams are carbon atoms. So carbon atoms, let's analyze these. We got a lot more dots. So let's look at the first box. We've got C with a 12 and a 6. And notice it's telling me I've got 6 protons and 6 neutrons. So I don't have to count all those little dots because it told me, okay? But let's count the electrons. I have 1, 2, 3, 4, 5, 6. All right, I have 6 electrons. All right. And then in the next box, it tells me I have 6 protons and 7 neutrons. And I have 1, 2, 3, 4, 5, 6 electrons. 6 electrons again. So that didn't change. But something changed. I now have 7 neutrons and not 6. And notice I went from 12 and 13. So this is telling me something about that number up there. Then in the next carbon, notice this number up here is now 14. I've got 6 protons and 8 neutrons. And 1, 2, 3, 4, 5, 6 electrons. So that didn't change. So let me think here. 6 plus 6 equals 12, which is that number that I have circled. 6 plus 7 equals 13, which is this number up here. And then 6 plus 8 equals 14, which is that number there. So what is that number up there? All right, well, let's look at the next information because I think it's going to tell us. So notice the type of notation used for atoms. So we'll use this notation right here. We've got an X, an A, and a Z, and it's going to tell us everything that it stands for. So an X is the chemical symbol of the element. Okay, we could kind of see that. Z is the atomic number, and that's the number on the bottom here. And up in our hydrogens, it's that 1. Okay, so that's the atomic number. And then A is the mass number. So the top number up here is the mass number. Okay. So now it's going to tell me some other things. All of these symbols here are notations that represent isotopes of carbon. And these symbols here represent isotopes of hydrogen. And then it tells me something else. The part of the atom where the protons and neutrons are is called the nucleus. So this tells me the protons and neutrons are in the nucleus. Okay, that is something I need to know. All of this is information. Okay, so this is stuff you can find in your textbook. You can look up the atom in your textbook. It'll be one of the early chapters. And it's going to have all this information if you want to look at another source. All right, so let's look at these questions based off the information we just analyzed. How many protons are found in each of the following? So we've got 3 hydrogen isotopes, and go back and see where, according to this symbol, the atomic number would be right here. All right, the atomic number is the number of protons. So the number of protons is 1. Now, how do I know that? Because I know the atomic number equals the number of protons. Now, notice I use my shorthand, but that helps. First of all, it helps me not have to write so many words, makes it go a little bit faster, and yet we still have the information. All right, and then it says how many neutrons are found in each of the following. Okay, so the top number is my mass number. Okay, mass number is the number of protons plus the number of neutrons. Okay, so that's 1 up there and 1 down there. So 1 minus 1 is 0. So the first one has 0. The second one is 2 minus 1, and that would be 1. The third one is 3 minus 1, which would be 2. So the first isotope has 0 neutrons, the second one has 1, and the third one has 2. If you will look at your diagrams from the information that you were given, count the gray dots. The first box doesn't have a gray dot. The second box has 1 gray dot. The third box has 2. But I also did it mathematically because we're not going to have boxes to look at and dots to count. All right, how many electrons are found in each of the following? Well, if you look back at the boxes, there's 1 electron in each. So I have 1 electron here, 1 there, and 1 there. All right, which structural characteristic do all hydrogen atoms have in common? All hydrogen atoms have 1 proton, and they all have 1 electron. The neutrons differ, but they have 1 electron and 1 proton. And notice he said the word atoms. All right, question number 5. What structural characteristic do all carbon atoms have in common? So once again, we're talking about atoms. So the same thing as the hydrogen, they're going to have, actually they have 6 protons and 6 electrons. And this is information I can find off the periodic table, but we had the diagrams we could look at, and we can count the number of dots if we wanted to. But we're not always going to have the dots, so we need to know how to find it. What does mass number tell you? Well, I kind of already told you what mass number tells us. So mass number is the number of protons plus the number of neutrons. Can you find the mass number of an element on the periodic table? No. It is not on the periodic table. And I'll just say PT for periodic table. Okay, what does the atomic number tell me? And can we find this on the periodic table? So the atomic number equals the number of protons, and it actually tells me what element it is. Can we find this on the periodic table? Yes. It is on the periodic table. And number 8, it says, as best as we can, define the term isotope. So this is how I remember the term isotope, and just basically going through what we just went through with this information and analyzing it. It's pretty simple to say that isotopes are atoms of the same element. We're not changing the element. The thing that's changing is the number of neutrons. So that's what we need to focus on. So isotopes are atoms of the same element with different number of neutrons. So the key word here is neutrons. The number of neutrons. That's what's different in isotopes. Okay, how does one isotope of carbon differ from another isotope of carbon? Number 9. How does one isotope of carbon differ from another isotope of carbon? They have different number of neutrons. Okay, so we have some more information to look at. This information is about atoms, ions, and masses of subatomic particles. Atoms, ions, and masses of subatomic particles. So when we talk about subatomic particles, what are we talking about? That would be our protons, neutrons, and electrons. All right, the atomic mass unit, which is also represented by AMUs, is a special unit for measuring the mass of very small particles, such as atoms. The relationship between AMU and grams is as follows, and this is what it is, a relationship. 1 AMU is actually equal to 1.66 times 10 to the 24th grams. So that is a conversion factor, and we will start using a lot of those soon. All right, it says note the following diagrams comparing atoms and ions. Atoms and ions. What is the difference between these two? So we need to look at the pictures. The dots still are the same, and figure out what is the difference between an atom and an ion. So here we have fluorine. How do I know it's fluorine? Because of the F. Okay, and you should know that symbol by now. So this fluorine's got 9 protons, and this other one, 9 protons. It has to, because if it had any more, it would be something else. And it has 10 neutrons, and this one has 10 neutrons. So these are not isotopes. This is the exact same atom. It's not an isotope of fluorine. It's 2 atoms of fluorine. Same number of protons and neutrons. And then notice the mass here, 18.9980 AMUs. And over here, it's 18.9985. So we've changed ever so slightly. So what changed? So let's count our electrons. We've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 electrons. Over here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over here, we have 10 electrons. Okay. So what else should I notice about this? This fluorine, we've got 19 and 9 there. We've got 19 and 9 there. And this one has a -1. Over here, we don't have, there's nothing there. And you have to remember that an atom has no charge. But this ion, it looks like, is a -1. Now, where did the -1 come from? Well, I had 9 electrons here. I have 10 electrons here, but I still have 9 positive. So a -10 plus a 9 equals -1, and that's where it comes from. All right, so with all that information, let's look at magnesium a little bit faster, because now we know a little bit more of what we're doing. Still the atom and the ion. We've got 12 protons, 12 neutrons, 12 protons, 12 neutrons. But our electrons are going to be different. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 electrons here. On this box, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. So there's a difference of 2 electrons here. And notice, this is magnesium, so Mg for the symbol. 24, 12, 24, and 12. And notice this has a little +2. We lost 2 electrons. We lost 2 electrons. We only have 10 here. So if we go back to what I did here, I had the electrons -10 plus the protons 12. -10 plus 12 is a +2. So that's where the +2 charge comes from. All right, this was a lot of information. So now that we have this information, let's look at some questions. Number 10. What is the structural difference? What is structurally different between an atom and an ion? No, this is the only structural difference between. Well, we noticed that the only difference between these two was the number of electrons. That's what was changing. We had 9 electrons here and then 10. And we had 12 electrons here and then 10. So the number of electrons is what was changing. So I'm going to use shorthand, number of electrons. Now, it's okay to use shorthand as long as you understand what it means. If you want to write the words out, write the words out. Number 11, in atomic mass units, AMUs, what is the mass of an electron? So we need to look back at our information here. And I'm going to look at fluorine because only 1 electron was added, so it'd be pretty easy to figure out the mass of 1. I'm going to take this mass, the 18.9985, and I'm going to subtract the other mass. And that will give me the mass of this one little electron. Okay? So what I'm going to do is take the second mass, 18.9985 AMUs, and subtract 18.9980, and you'll get 0.0005 AMU. So that is the mass of an electron in AMUs. All right, easy enough. Number 12, is most of the mass of the atom located in the nucleus or outside of the nucleus? And how do I know? Well, look at the little mass of the electron, 0.005. Where is all this other mass coming from? This 18.99, this 0.005, that's not that much of a difference. So where is the mass coming from? It has to be coming from the protons and the neutrons. So, is most of the mass of an atom located in the nucleus or outside? It's in the nucleus. How do I know? Because the protons and neutrons are in the nucleus. Okay, so number 13. If protons and neutrons have the same mass, what is the approximate mass of a proton and neutron in atomic mass units? So they're saying their mass is the same. So let's go back up and look at fluorine. Fluorine, the mass is 18.99. And I've got 9 protons and 10 neutrons. If I add those two together, that gives me 19. 19 is very close to 18.99. So we can use that and say that the mass of the protons and the neutrons, they're about 1 AMU apiece. And if we look at magnesium, magnesium has 12 protons and 12 neutrons. If we add both of those together, that's 24, and its mass is 23.9978, which is almost 24. So we're estimating they approximately have the mass of 1 AMU. Okay, number 14. The mass of carbon-14 is about 14 AMUs. Carbon-14. Does this agree with what you determined in questions 11 and 13? Okay, 11 and 13, we said that each proton and neutron had a mass of 1 AMU. So carbon-14, we've got 6 protons. And how many neutrons do I have? I get that by subtracting 14 minus 6. So that would be 8. So 16 plus 6 plus 8 equals 14. Okay, so this is all equaling to this number. If each of them are 1, then yes, it does. Yes. Because there's 14 protons and neutrons, and each of them equal 1 AMU, which would be 14. All right, number 15. The charge in the upper right-hand corner of an element symbol, so example for fluorine, it was F with a -1. Why isn't it +1 or some other number? Well, mathematically, it just can't. Okay, we've got 10 electrons, and we're going to represent that with a negative number. And then we have 9 protons, which all have a positive charge. So when you add those two numbers together, it's a -1. Mathematically, that is only possibility. Okay, number 16. What is the charge on every atom? Why is this the charge? Okay, it's kind of a trick question here. Atoms do not have a charge. So atoms are neutral. Or you could say 0. Why is this a charge? Because the number of electrons equals the number of protons. Number 17, how do you determine the charge of an ion? Well, the way I determine it is I add the number of protons and the number of electrons, but always keep the number of electrons as a negative number. That way you'll know what the charge is. So you're going to compare the protons and electrons. All right, number 18. An oxygen ion, we've got to pay attention to the words, has a -2 charge. And we can look on the periodic table to help us get this information too, because we have to. How many protons does an oxygen ion have? Now, you probably don't know that unless you look on the periodic table. So you look on the periodic table and it has 8 protons. How many electrons does the oxygen ion have? Notice, again, it's asking about an ion. It didn't ask me about the atom. The atom would have 8, okay? The ion has to have more than 8 because it has a -2 charge. So it has to have more electrons than it does protons. So basically, it goes back to simple math. I've got plus, let me change that. I've got +8 plus a certain number is going to equal -2. So this has to be a -10. So how many electrons does it have? It has 10. All right, let's do another one. An aluminum ion, so there's that word again, has a +3. How many protons does aluminum have? Well, you look on the periodic table, aluminum has 13 protons. So how many electrons does aluminum have? Now notice that aluminum is positive. It has a +3. So you could reason it out, or we do exactly what we did in number 18. We're going to take +13, and we're just going to keep it with an addition. And then our electrons will be a negative number. And this is going to equal a +3. So 13 plus what is 3? Well, we have to subtract a certain amount of electrons, so that would be 10. And that's going to give us this +3. So how many electrons does an aluminum ion have? It has 10 electrons. Okay, that concludes the Chem Quest number 8. So you are ready to do the skill practice. So get the skill practice done, and then you can correct your answers.